Now let us look into the rules to solve the block diagram reduction. The first rule is shifting the summing points or interchanging the summing points. Here, let's consider this particular block diagram wherein we have two summing points which has input of x and y. Now, for this particular block diagram, the output becomes r of s plus or minus x or plus or minus y. Now, when I interchange both of these summing points, there will be no change in the output. When there is no change in the output, then this rule is valid. Second rule is for the blocks in series. Now let me consider this particular block wherein we have G1 of s in series with G2 of s, and thus the output becomes a multiplication of these two blocks, that is G1 of s into G2 of s. They get multiplied only when they are directly connected, or else you can't multiply these two blocks. Now the rule number 3 is when the blocks are in parallel. Now consider this particular block diagram wherein G1 of s is in parallel with G2 of s. Both are in same direction. When they are in same direction, it simply gets added. Here the resulting output block will be G1 of s plus G2 of s. They get added only if they are in same direction, or else you can't add these blocks. Now rule number 4 is shifting the summing point after a block. Now let me consider this particular block diagram wherein the summing point has an input of x and a gain block is g of s. For this particular block diagram, the output c of s is r of s plus or minus x into g of s. Now when I need to shift this summing point after this g of s block, I simply need to multiply the gain block. Now the gain block here is g of s, so you need to multiply g of s with the summing point. Then the output remains same for this block and this block. Only if the output remains same, rule 4 is satisfied. Now rule number 5, which is shifting the summing point before a block. Now let me consider this particular block diagram which has a summing point plus or minus x, wherein the output for this block diagram is r of s into g of s plus or minus x. Now when I need to shift this summing point before this block, I simply need to divide 1 by g of s. The g of s is the gain here. So whatever gain value you get while solving this block diagram reduction, the same gain value need to be divided here. Then the c of s remains same for this block diagram and this block diagram, and thus the rule is valid. Now rule number 6, which is shifting the takeoff point before the block. Now here the takeoff point is y of s, and the c of s for this block diagram is r of s into g of s, and y of s is simply r of s into g of s. Now when I shift the takeoff point before this block, you simply need to multiply the same gain block in the takeoff point. Only then you will receive the same r of s and c of s as this block diagram. Only if the outputs match, the rule number 6 is valid. Then rule number 7, which is same as the previous rule, shifting the takeoff point just after a block. Now you can see y of s is here, and the output for this particular block diagram is r of s into g of s, and y of s is simply r of s. When you shift this takeoff point here after this g of s, you simply need to divide the gain block. While solving the block diagram reduction, whatever gain block you receive here, the same gain should be divided. Only then the c of s and y of s of this block diagram and this block diagram will remain same, and then the rule 7 is valid.